July 19th, 1971. A freight train rushes down the North Thompson River Valley in central British Columbia. The engines are pulling 65 cars of elemental sulfur and 10 propane tankers down to the coast.
Cars of a westbound freight train jumped the rails at Vinsula today, a farming community 16 miles north of Kamloops in the North Thompson River Valley. One propane tanker immediately exploded, setting fire to huge mounds of sulfur spilled from the other cars. Sulfur dioxide gas produced by the burning sulfur drifted down the river valley, severely hampering firefighting. The cause of the derailment is still unknown, but...
This is color infrared photographs. They were taken at a height of 12,000 feet with a 12-inch lens to give a scale of 1,000 foot to the inch. And this scale is sufficient to see damage on very small trees, say a hardwood tree maybe 3 feet high.
Peter Murtha is an air photo interpreter with the Canadian Forestry Service. 10 days after the train wreck, he was at Vinsula taking color infrared photographs of the vegetation damaged by the sulfur dioxide gas. Now he interprets these photos with a stereoscope in Ottawa.
On the color infrared photographs, the hardwood which had been killed showed up a yellow color, and the conifer needles showed up a whitish color. If you ask, what does a healthy tree look like? It's sort of like a mechanic listening to a motor running. He knows when it's running right, and he knows when it's not running right. When I look at a tree, I can tell whether something's the matter with it.
Man's understanding of the forest has largely been determined by how much of it he has been capable of seeing. To the Indian, the forest was his brother. The settler saw the forest as an obstacle, which kept the sun and the plow from the fields he dreamed of. White pine and spruce were soon viewed as useful construction materials. Men from all over headed for Canada's pine stands. They built mammoth wooden trestles for the new railway which was opening up the country. Man's bird's eye view developed from small military balloons during the American Civil War to the enormous kite balloons used in the First World War. Photographs were first taken from the air to spy on enemy troop movements. And air photo interpreters became the eyes of the armed forces. Peacetime allowed technical advances sparked by military needs to be applied in map-making. From this 1921 photograph of log booms on the Ottawa River to these 10,000 square mile photos of the Mackenzie River Valley and southern Vancouver Island, taken from a satellite 600 miles in space, man's understanding of his planet has been determined by how much of it he's been capable of seeing. Vancouver Island, British Columbia. Albert Bowman, seasoned faller, cuts into a 500-year-old Douglas fir. In 10 minutes, she will be down. Another 5,000 feet of timber to become newsprint and plywood. Nearly one half of Canada is covered by forest, but in just a few years, there will be little exploitable virgin forest left in North America. In an effort to determine how much is being cut and how fast it is regenerating, forest managers are using satellite pictures taken automatically every 18 days.
What we were doing is to use the diazo transparency, which have three colors, green, red, and blue. And we can combine different bands to find what color combination would give best result for recognition of lakes, forests, roads, railways, highways.
Jim Lee works at the Pacific Forest Research Center in Victoria, BC. He is experimenting with adding color to several different spectral bands from satellite images to aid him in determining the extent of logging operations on Vancouver Island. As logging companies continue to exploit the forest, forest managers use satellite images and lower-level aerial photographs to record the progress of their cutting.
We have high-level air photographs to show progressive logging over time during that period. So when you superimpose, there is a different density in there. So we can get the number of acreages for different patches of timber that have been taken out between those two air photographs.
3,000 miles away, in New Brunswick, the forest is being consumed by a more insidious predator. Each year, during 14 hectic days in mid-July, observers in 6 Cessna aircraft fly almost every square mile of New Brunswick. They spend up to 12 hours a day in the air, sketch mapping by hand hundreds of thousands of acres of dying trees. The culprit, which threatens the whole of eastern Canada's forest economy, is a tiny insect, the spruce budworm. The larvae have an appetite for young needles of the spruce and fir, and the bug has now affected more than 56 million acres of Canadian forest. Man's response has been to spray.
They realize they've painted themselves into a corner. They started spraying, and we can't get out of spraying. The only way to get out of it is to commit the forest to the budworm and let the budworm kill the mature stands. And eventually, the infestation will collapse, because all past history has shown that the infestation only lasts 10 years, and yet now I'm talking about one that's been going on 22 years. We're just competing with nature for who shall take the crop, man or the insect.
David Greenbank, Canadian Forestry Service, New Brunswick.
Okay, takeoffs. Target temperature. We just use hand nets so we can catch them on the takeoff flight and get the sex ratio. We found that mostly females in the early part of the evening involved, and there are some indications that males get involved after dark.
Females? All females.
Greenbank is coordinating a radar research study of the evening dispersal process of spruce budworm moths.
Radar, this is observation platform. Come in.
Tower, do you read me? Do you see any unusual insects passing by in unusual numbers? Because I think they're being concentrated by a cold outflow of air passing by suddenly.
Mayflies are still flying canopy level, and they should be on your screen. Over.
Is it one at 36? No. Put down that one at 72. At a range of 0.50 nautical miles.
Dr. Glenn Schaefer is able to determine the sex of individual budworm moths by isolating them on his radar screen and measuring their wing beat frequency.
There's one.
Yeah, that's your 82 or 3 again.
All right, we'll have that.
The most impressive piece of information that's come out of Dr. Schaefer's radar team's work is that the moths aren't uniformly distributed in the airspace, but tend to band in layers. And we've never dared think about this before, but now, because of the concentrations of moths, we think they're a possible target for spraying in the airspace while the moths are airborne.
The largest forest fire of the season is racing out of control about 6 miles southwest of Salmon Arm in central British Columbia. 50-mile-an-hour winds whipped the enormous flame through 15,000 acres of timber and destroyed more than 40 homes. Thousands of acres of lush farming valley are still covered with thick clouds of smoke, turning a bright sunny day into semi-darkness.
Each year, 2 million acres of the Canadian woods go up in smoke. In an effort to better understand forest fires, man is experimenting with a new tool which can chart the behavior patterns of fires. A conventional aerial photograph taken during a fire shows nothing but a dense cloud of smoke. A picture of the same fire, produced by a thermal infrared scanner, reveals heat patterns, human body. Breast cancer and other tumors are revealed in thermographs, which present a visual color display of temperature gradients. A twin-engine Aztec aircraft, flying hundreds of feet above a fire near Hope, BC, is equipped with a thermal infrared scanner linked to a television monitor. The crew can chart the development of the fire by regularly photographing the TV screen, which assigns colors to different temperature readings. Infrared thermography has many possible applications in forestry research, and Canada is a world leader in this field of remote sensing. ERTS is the Earth Resources Technology satellite. It circles our planet continuously, covering the whole surface of the Earth every 18 days. The images it produces cover 100 miles by 100 miles, and conventional aircraft flying at a lower altitude can photograph smaller areas selected from the ERTS image for detailed study. At the Forest Management Institute in Ottawa, John Whiteman fits together several ERTS scenes to construct a mosaic of satellite images which form the province of Ontario. Seasonal mosaics, using either ERTS images or larger-scale air photographs, are used as an aid in forest inventory studies and in constructing maps. John also works on the Color Additive Viewer, a sophisticated system of coloring several spectral bands from satellite images.
If I take 4 bands of the summer image of the Mackenzie Delta in black and white and pass them through the appropriate colored filters, I can immediately make myself a color composite. Now this is a big advantage because color composites are not made available for every ERTS scene taken, so you've got to have the facility of making one yourself. Here, for example, on this lake, we can see a large sediment plume going into it. You can see typical delta channels, meander scars, and here at the mouth of the Mackenzie, we can see the tremendous accumulation of the sediment load flowing into the Arctic. Now that we have ERTS providing continuous coverage of areas such as the Mackenzie Delta, it provides us with an opportunity to monitor the changes in these dynamic phenomena almost as they happen and within sometimes hours of when they happen.
This photograph of blowdown from a hurricane in 1922 was taken from a low-flying aircraft. Color-enhanced ERTS satellite imagery shows the course of a similar hurricane. This mosaic gives a clear view of the storm's path as it raced through hundreds of miles of forest. When experimenting with enhancing several spectral bands with various color combinations, an unusual tone was detected on this Earth's image of central British Columbia. Photographs shot at a lower altitude identified the patch as Douglas fir, severely defoliated by spruce budworm. Wawa, Ontario, site of the Algoma Steel Company's iron sintering plant. Sulfur dioxide from Algoma's stacks has killed or damaged vegetation over a 350 square mile area. A prevailing southwesterly wind concentrates the defoliation into a plume-shaped area away from the town. From an altitude of 4,000 feet, color infrared photographs show the damaged area as a gray tone. The healthy outlying vegetation is a red color. Sulfur dioxide pollution has long been a serious problem in industrialized nations. Canada's most notable example is at Sudbury, Ontario, where the world's tallest stack spews sulfur dioxide into the atmosphere, a byproduct of the 2,300 tons of sulfuric acid produced each day in the nickel smelter below. At Sudbury, the factors influencing the massive area of defoliation are complex and interrelated. At Wawa, the situation is much simpler. The Ontario government and the Forest Management Institute have studied the effect of sulfur dioxide gas on the nearby vegetation.
In the Wawa case, we had some very, very severe damage. At the medium level of damage, most of the white birch had been killed. In the heavy kill areas, all tree growth had been killed and only grasses remained. And in the total kill area, there was nothing growing. It's as bald as the moon.
Working with a color enhancement device, which slices the grayscale into 32 layers and assigns a color to each, Peter Murtha is able to delineate the degrees of vegetation damage from satellite imagery.
When we obtained satellite shots taken from the Earth's satellite, the areas of total kill, heavy damage, and medium damage were visible on the satellite image when they were enhanced on the scanning densitometer. The densitometer was used to differentiate the zones.
A knowledge of the height of trees provides man with a useful guide to the amount of timber present, its value, and what it may be used for. The British Columbia Forest Service uses twin cameras mounted on a boom, which take simultaneous photographs of the forest below. These two photos can then be viewed in stereo, and the height of trees measured on a stereoscope. Another tool for determining tree height, developed by Canada's Forest Management Institute, is the Airborne Radar Altimeter. A radar dish mounted beneath a plane accurately measures the distance between the aircraft and tree crowns or the forest floor below. Alan Aldred is now experimenting with the use of a laser device mounted in a plane to determine the height of trees.
It's this little beam of light no wider than about an inch, and it hits the ground or vegetation land and bounces back up to the aircraft again. And the time taken to do all this is converted into distance. And by doing this, it can show the thickness all the way along as a continuous trace on a chart. And that chart then shows how tall the forest is, how thick it is, if you like, But in order to be useful, we have to know where the transects were flown when we do the work, and we take aerial photography with a camera at the same time. We usually have to then transfer that information onto the photography that the interpreter has used for his interpretation work.
Despite this impressive array of technological aids, some information can only be obtained by physically trekking through the forest on foot.
It's a little bit of a hassle being a head chainman because you've got to go through most of the things other people can walk around. If there's a big, thick stand of spruce that you can hardly crawl through and your line goes through it, you've got to go through it, whereas the guy on the rear chain can skirt around it and pick the easiest road to go.
18.
And one of the lines we did yesterday, about 80% of the line was through swamp with standing water, and in these cases the bugs are fantastic.
Oh, there are boulders there.
It's the soil sample which will give us a better understanding of why there is a certain type of forest there. We need to know the texture of the soil, we need to know the depth of the various horizons, because they tell us how the water is going to percolate through that soil, in other words, how wet the trees' feet are going to be.
Your B horizon. Your B horizon is pretty well the same.
Birch. Birch. Spruce. Spruce.
Coverage,
Birch.
class 1.
Fir.
Sociability, class 1.
Birch.
And frequency, 25%.
Builder. Rewind. Azimuth 60, vertical angle 30. At 60, rewound.
With so much satellite imagery available to forest managers, there is a need to produce a coding system for positive identification of forest tree species from satellite data. In the Larose Research Forest near Ottawa, a light meter mounted on a 65-foot tower measures the amount of light reflected upward from tree crowns. 600 miles in space, the Earth's satellite sees this area of forest as a certain tone. Colors change, however, with seasonal changes in leaf and snow cover. In his Ottawa office, Denny Kalensky is experimenting with the use of a computer, which can read Earth's satellite data and automatically identify forest patterns. The computer is programmed to recognize tree species groups by their own idiosyncratic colors. Forest managers call these tones signatures. Each signature is assigned a letter, and groups of letters are circled. When each grouping is given a color, 4 thematic maps are formed. One map for each of the 4 spectral bands that are contained in a satellite picture. Tiny details found on Earth's satellite images, enhanced by the computer, identify tree species, forest damage, and deepen man's understanding of his forest. Perhaps this broader view can return man to a closer harmony with his forest, the natural provider from where he began.